Hi everybody, and welcome to tonight's video where we're going to be talking about linear modeling. And modeling in general is a mathematical term used when we can describe the relationship between two variables with an equation. And we're going to find that almost all of the functions that we've seen so far can be used in modeling, right? So it's going to be depending on what the relationship is between two variables. That's going to affect whether or not we can use a certain function. So in our case here, if the relationship has a constant average rate of change, so we're increasing or decreasing by the same amount over time or as the relationship grows, then we can use a linear equation for our model. So that's what we're going to discover here. We're going to have a constant average rate of change, and that will make it possible for us to use a linear equation to model the situation. Now here you'll notice our linear model is, the basic form is f of x equals mx plus b, right? That's our linear function. But note here, you might want to write this down, that when we have these different functions, we're almost always going to use like a different letter. It's not going to be f of x. So you might see like a capital C of p, right? Where the function will represent the cost of something, and p, or some other variable is going to be inside here instead of x. So just get used to this is the model or the form, but you're going to see different names for these functions and maybe even different variables used depending on what we're going to try to model. So if this is our standard form of the equation or the model, f of x equals mx plus b, m again is this constant average rate of change, and b, keeping in mind that b would normally be like the y-intercept, and the y-intercept is where x equals 0, so it's the value of f of 0. And another way to think of that is that m is the amount that is consistently being charged, like a monthly or annual fee, and b is the amount that you start with, like an entry fee or initial investment. And so that's kind of related to most of the examples that we're going to do with this, but think of m as the constant or consistent change. So what's happening every time as you move forward. And then b is, what do you start with? Do you start with the amount of money and then you're decreasing every month, or do you start with some value and you add to it every month? Whatever you're starting with is what b is going to be, and then whatever is the consistent change, or something that's being charged over time or something like that, that's going to be m. So for example over here, let's say if you want to describe or you want to model a subscription to an online music service like Spotify, for example, and there's a one-time sign-up fee of $15, and then the charge is $9 a month after that. So let's use a linear model or a linear function to model our payment. So first of all, I'll call this function s of m, right? And in this case, well, maybe I won't use m because that'll be confusing. You'll confuse it with m of x. Let's just call it s of x for now, okay? So the s is my subscription to Spotify, okay? And so I want to figure out what m and b are and be able to plug them into this model, s of x equals mx plus b. And so this model represents my cost for my subscription to Spotify. So we'll write that off to the side too. So s of x represents the cost of Spotify over time, right? Where x is a number of months, or you could say x represents months that were subscribed, okay? Okay, so here's my model. I want to figure out what m and b are and then plug it in to determine my equation. So we said m is the constant rate of change, okay? So here, if I'm looking at this, what is the change that's occurring each time? That would be the $9 a month, right? Because every month that I'm subscribed to Spotify, it's going to charge me $9 a month. So I know that M is that charge that I'm getting each month, $9. Then this one-time startup fee, right? When I sign up for the service, they want me to pay $15 to start. And so that would be at 0 months, right? Just to start, I would have to pay $15. So B equals 15. So if I want to figure out my model for this, S of x, the function S of x, is going to be 9x plus 15, where x represents the months that I'm subscribed to Spotify. All right, so once we have a model for our situation, we can use it to find valuable information. So if we continue with this subscription example, and we had our model, S of x equals 9x plus 15. And now I want to figure out some information about my subscription to Spotify. So how much will I have paid after subscribing for 18 months? So thinking about long term, whether or not it's worth it to buy music as I want to over iTunes, or if I should just pay this $9 a month for Spotify. Let's say I'm subscribed for 18 months, a year and a half. So that would be S of 18, because remember, X is representing the number of months. So we have 9 times 18 plus 15. So 9 times 18 plus 15, 9 times 18, you can use your calculators if you need to. 90 plus 72 is 162 plus 15. And so a total of, after 18 months, I will have paid 177, to subscribe to Spotify. Right? So my total would be $177 paid for subscribing for 18 months. Okay. Then how many months will it be until I spend a total of $195? So if I'm spent a total of $195, that means S of x total, because remember the function or the model represents our total amount spent. So if S of x equals $195, to determine how many months, I would say 195 is my total value of S of x equals 9x plus 15. So I would just solve for x. So I subtract 15 from each side, and I get 180 equals 9x. And now I divide both sides by 9, and I would get that 20 months, or 20 equals x. So after 20 months, I will have spent $195. So that would be my answer there. Now, the last thing that we're going to see in some of our examples in the book, it wants to know what's the implied domain of our model. So what are my potential values for x? Well, think about what x represents. X equals months that we are subscribed to Spotify. So I can't have negative months, right? I can't say I was subscribed for -4 months, right? We don't describe time with negative numbers. So we would say that x has to be greater than or equal to 0, right? Because we could say we just start our subscription and we start that at 0. So the implied domain of our model is that x is greater than or equal to 0. And remember, the ways that we can write that is interval notation. So we could say 0 to infinity included, or we could say set builder notation, all x values, such that x is greater than or equal to 0. Those are our two ways to describe this. So we want to think about, when it asks us what our implied domain of our model is, we want to think about potentially what the x value represents, and then what potential answers we could have in there. Okay. Now what you'll see is there's going to be some where this function was increasing. So we know that x can potentially go on for any value greater than or equal to 0. But you'll have functions where they're decreasing, and so you'll have to actually find that point where it hits 0 or where it intercepts the x-axis, because after that, that's like the end time. That's where you maybe you ran out of money or something like that. And we'll do examples like that in class and on the homework tomorrow. Lastly, what we want to talk about here is that mathematical modeling is definitely the most applicable skill you will learn in this class, right? We're going to do this a lot from now until the end of the year. I know word problems aren't everybody's favorite, but it's actually going to be the most useful thing you'll probably learn. So if you pursue business, or if you ever want to make your own budget or determine how much you can afford to spend on something, or whether or not opening a savings account is a good investment, that sort of thing, you'll have all kinds of opportunities to apply mathematical modeling, especially if you're getting to business, because you'll want to be using it to determine supply and demand. So you may have talked about supply and demand if you are in economics class already, but let's do an example with that. So suppose we have two models here, one that represents supply and one that represents demand, so S of P and D of P. And let's say this is for iPhones, where P represents the price. So the supply for iPhones is modeled by this equation, 60p minus 900, and the demand is modeled by this equation. So if I'm a business and I'm considering supply and demand, I want to find what's called the equilibrium price, or the equilibrium point, where these two are equal. Because once supply is greater than demand, that means I have extra product and I'd have to put it on sale, right? I'd be losing money maybe. Once demand is too high, if demand is higher than supply, that means low on inventory and people are going to be disinterested, and maybe I'm going to be losing sales. So the best point is the equilibrium price, right? And so that's what we want to find. And the equilibrium price is where supply and demand are equal. So we're left with no extra inventory, and we're also left with no disappointed customers, basically. So what we want to do is figure out where supply equals demand. So S of P, where that is equal to D of P. Okay? And so in this case, I would just substitute in my models. So 60p minus 900, I want to find out where that equals 15p plus 2850. Okay? And so what I would do here is just solve for p. So I would add 15p to each side. And so we would get 75p minus 900 equals 2850. Then we would add 900 to each side because we're essentially solving for p here. And so we'd get 75p equals 3750. And now divide both sides by 75. And we'll get p equals 50. Okay, and so that's the equilibrium price. So that price, remember, P represents price. So if I charge $50 for a phone, then supply will equal demand. Now here it wants to determine where supply is greater than demand. That's the one that we want to avoid, right? So where supply is greater than demand is the one that we want to avoid. We don't really like where demand is greater than supply, because we might lose customers on that, but it also doesn't hurt us too much because that just means that demand is high, right? And it's good for us. But if supply is greater than demand, then we're going to have to be losing money, because then we'll have to put it on sale and stuff like that. So again, you would do the same thing. You would just set it up so that you have your S of P, which is 60p minus 900, is greater than negative 15p plus 2850. And you solve this much in the same way, but remember, if you have an inequality, if you ever divide by a negative number or multiply by a negative number, you'd have to flip the inequality. But other than that, it's the same process. So we would add 15p to each side, and then we would end up with 75p minus 900 is greater than 2850. You're going to end up seeing that in the end, p is going to be the same, but there's going to be the greater than sign. So we again are going to have 75p is greater than 3750, divide by 75, and you get that p is greater than 50. So when p is greater than 50, if I charge anything more than $50, then I'm going to find that my supply is greater than demand, and that's what I want to avoid. Okay, so we're going to do some problems like this tomorrow in class. We'll have some word problems. We'll just kind of have to translate them into a linear model and then figure out what each question is exactly asking us. And we'll use these notes tomorrow. So make sure you bring these to class, and I will see you then. Have a great night.